Today, I will test this scale based on legal metrology.
What's legal metrology?
Glad you asked. Legal metrology has to do with the laws around measurement. One task that NIST, OIML, and the NRC have to carry out is to ensure that every transaction that occurs across the scale is fair for all. I have here a breakdown for the requirements of what it takes for a scale to be legal for trade in Canada, which can be found on the Measurement Canada website.
So let's get the coffee going, and now let's start testing. The first test we're going to do is discrimination. We're going to add a gram to take the scale out of the automatic zero tracking range, and then we're going to add the smallest graduation it should be able to read. In this case, 100 milligrams or 0.1 gram. After a moment to settle, we see it actually moves up to 1.1 grams. Next, we do the same thing at the top of the range of the scale, and in this case that's 3 kilograms, and so now we will add the 0.1 gram. For discrimination, this scale fails. The next test we do is called blanking, and that's where we want to see this scale not be able to display any value that's more than 5% of its maximum weight. We're able to determine where the blanking is occurring, and in this case it's at 10% of the maximum weight. For display blanking, this scale fails. The next test we do is called increasing decreasing. The increasing decreasing test is where we take points called critical test points where the limit of error is increased, and we want to ensure that the scale is within tolerances at those points. We start at 0, go up to maximum, making a point to hit all those critical test points, and then we do from the top back down to the bottom again. For increasing decreasing, this scale fails. This next test is called repeatability. We take a load that is equivalent to half of the maximum weight of the scale, we place it in the same location, the same way, and we record the value. After 3 weighments, the values must be within the limit of error. For repeatability, this scale passes. It still fails in performance because 3 grams is outside of the 0.3 grams that is allowed. This next test is called eccentricity. We take 1/3 of the maximum capacity of the scale, place it in the 4 corners, recording the values. In order to pass, the difference between the top value and the bottom value must be within the prescribed limit of error. For eccentricity, this scale fails. The fact that the deck is plastic means that it can flex, and it will be changing the way that the load is hitting the load cell.
We have carried out the most applicable of the 17 odd tests that would need to be carried out on a scale like this in order for it to be verified in the field. Now the question remains, could it be legal for trade? If a scale is not legal for trade, it can be as accurate or inaccurate as you are willing to pay for. This scale has 0.1 gram graduation. The scale is out roughly 0.2%, which on a 15 gram shot of espresso amounts to a difference of 0.03 grams. Not enough to care about. On a pour over with 500 grams of water to add, this is 1 gram, or 1 milliliter, or 1 cubic centimeter. Not enough to care about.
Repeatability can play a bigger role with low-cost scales, but with 25 weighments at 18 grams, I saw 0.06 grams standard deviation, which should not be enough for you to care about. And on 500 grams of water, it worked out to be 1.6 grams, which again, not significant. So tell me, what scale are you using, and how do you know how accurate it may or may not be? This scale is good enough for what I use it for, and you can decide if it will be good enough for you. There's a link in the description for the scale, and I hope you found this informative. Thank you for watching.